This is Algebra 1, Unit 9, Lesson 7, more work with quadratic equations. Okay, so now we have learned three methods to solve quadratic equations. We can do it by factoring, completing the square, and the quadratic formula. So you can solve it any way you want to, unless you are told to solve it a specific way. But remember, before solving a quadratic equation by any method, it must be in the form ax squared plus bx plus c equals 0. So it has to be in descending order, equal to 0 before you start. Okay, so let's try this out. Let's do some practice. Solve each equation by the method indicated. So let's look at the first one. We want to do it by factoring. So first thing we have to do, get it equal to 0. So to get it equal to 0, we have to move the 8x and the minus 2. So I'm going to minus the 8x. That goes under the 5. And add the 2. Goes under the 12. So that gives me x squared minus 3x, negative 12 plus 2 is minus 10, is equal to 0. All right, so I've got it equal to 0. Now if I want to do this by factoring, I have to double bubble. All right, we know it's x squared, so it's got to be x and x. Negative on the end means it's going to be plus and minus. The factors of negative 10 are negative 5 and positive 2 to give me negative 3. Set each bubble equal to 0. And solve for x. This one will be negative 2. And this one will be x equals 5. So this was done by factoring. Those are my two zeros. Okay, now let's try completing the square. First thing we want to do before we do anything else is get it equal to 0. So we want to add the 3x and subtract the 4. So add the 3x goes here under the 15x, and then minus the 4 goes under the 24. Combine your terms, you get x squared minus 12x plus 20 is equal to 0. So there's my form. All right, now I want to complete the square. So when I complete the square, I want to move the c value over. Remember, the c value is the third term, the constant term. So I'm going to move that over. X squared minus 12x is equal to negative 20. Watch your signs. Now remember, when you complete the square, you have to take half the b value and square it. All right, remember the b value is the term on the, on the x here is negative 12. That's the b. So half of that would be negative 6, square it. And you have to add it to both sides because you can't add it to just one side. You get x squared minus 12x plus 36 is equal to negative 20 plus 36. Okay, so now to complete the square, we have to double bubble this. Remember, it's going to have identical factors, so this is going to be x minus 6, x minus 6. And then negative 20 plus 36 is negative 16. Or 16, not negative 16, sorry. Okay, now x minus 6 can be written as x minus 6 quantity squared is equal to 16. Okay, now once we've got it to this point, if we want to solve it for x, all we have to do is take the square root of both sides. So take the square root of this and the square root of this. Remember, the square root will cancel out the square. These cancel each other out, leaving just x minus 6. But how many square roots does this have? It has 2. It has positive and negative, plus or minus 4. So I have two equations. I have x minus 6 is equal to positive 4, and I have x minus 6 is equal to negative 4. Solving for x, add the 6, x is equal to 10, and then add the 6 here, x is equal to 2. Okay, so you can see that I could solve this by completing the square. Now, if I was given my choice, I probably would have factored this because I know this factors quite nicely. I could have factored this and done it. But since this said to complete the square, I completed the square. You have to know both methods in case you are asked specifically to solve it a certain way. All right, let's try the next one. All right, the next two we're going to solve by the quadratic formula. We're going to solve it to the nearest tenth and in simplest radical form. So remember the quadratic formula that we've been working on is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so in order to do the a, b, and c, it has to be in standard form. So equal to 0 and descending order. So let's get this equal to 0. We're going to minus the 5x and minus the 15. So minus 5x goes here, minus 15 goes here. So that gives me x squared, negative 3 and negative 5 is negative 8x, 16 and negative 15 is plus 1, is equal to 0. Okay, so this one doesn't factor anyway, so we can't double bubble it, but we have to use the quadratic formula. So we're going to round this to the nearest tenth, so we just have to use the formula. So let's figure out what our a, b, and c are. All right, so a is what's in front of the x squared, is a 1. B is what's in front of the x, that's going to be negative 8. And then c is going to be the third term, the constant term, which is 1. All right, so let's plug these values into this formula. All right, negative b. Well, if this is negative 8, what would negative b be? It would be positive 8. Plus or minus. All right, and then b squared would be negative 8 squared minus 4 times 1 times 1. So 4 times a times c, all over 2 times 1. Okay, now what's under the square root I can put in my calculator, remember? Make sure you use the parentheses, especially with the negative 8 squared, because if you don't, you're going to get the wrong answer, because it won't square the negative. All right, so I'm going to go to my calculator. I'm going to do parenthesis, negative 8 quantity, whoops, too many parentheses, negative 8 quantity squared, minus 4 parenthesis 1 parenthesis parenthesis 1. Okay, notice that's exactly what I wrote on my paper, parentheses all. So that gives me 60. So if I go back here, I can put on my paper x equals 8 plus or minus the square root of 60 over 2. Okay, now this says we're going to round this to the nearest tenth, so I'm not worried about breaking this down into simplest radical form. But I do want to remember that this is actually 2 answers. This is x equals 8 plus the square root of 60 divided by 2, and it's also x equals 8 minus the square root of 60 divided by 2. So when I want to round this to the nearest tenth, I'm going to put this in my calculator. When you do this, you want to put the whole numerator in, divided by the denominator, or use the alpha key and put the entire thing in. All right, so if I go to this, say I wanted to use my alpha key, so it looks like it's on the paper. I'm going to use my alpha key, alpha y equals, to make it look like a fraction. This is going to be 8 plus the square root of 60, and then divided by 2. And that gives me, it said rounded to the nearest tenth, so this will be 7.9. Okay, now for the other one, well, I already have this in here. All that's got to change is I got to change the plus to a minus. So just go up and grab it, press enter, arrow back from plus, and change the plus to a minus. And press enter, and this rounds off to be 0.1 because it'll stay there. So x is going to equal 0.1. Okay, so there we go. That is rounded to the nearest tenth. All right, let's try one in simplest radical form. Again, get it equal to 0. Add the 2x minus the 7. Add the 2x minus the 7. X squared plus 6x minus 5 is equal to 0. Okay, so a value is going to be 1. That's for the x squared. B will be 6. C will be negative 5. Watch your signs. X equals negative b would be negative 6 plus or minus the square root of b squared, 6 squared, minus 4 times 1 times negative 5, all over 2 times 1. All right, this is going to go in my calculator. What's under the square root? So in my calculator, I have parenthesis 6 squared minus 4 times 1 times negative 5. And I get 56. All over 2 times 1 is 2. All right, now this says simplest radical form, so I have to know what perfect square goes into 56. Well, 56 is actually equal to, square root of 56 has a 4 in it. It's 4 times 14. So that's going to give you 2 times the square root of 14. Negative 6 plus or minus 2 times the square root of 14, all over 2. Now, I want to split this up into separate fractions, because both of these are being divided by 2. Negative 6 over 2 plus or minus 2 radical 14 over 2. So negative 6 over 2 is equal to 3 plus or minus, and then these 2's are going to cancel, leaving 14. So remember, this is really two answers. 3 plus the square root of 14 and 3 minus the square root of 14. So that is your final answer. All right, so let's look at this quadratic. The quadratic f of x is equal to x minus h squared plus k is shown in the graph. So this is vertex form of the parabola. So vertex form, what are the values of h and k? It would be the vertex. Okay, so the vertex right here is at the point 2, 4. So h will be 2, and then k will be 4, so the vertex is at 2, 4. So if we know that, the equation, all we have to do is plug in the h and k, would be x minus 2 quantity squared plus 4. Okay, that's vertex form. So what happens when you try to find the zeros using vertex form? All right, remember the zeros is when y equals 0. Remember f of x stands for y. X minus 2 squared plus 4 is equal to 0. Move the minus 4 over. X minus 2 squared equals negative 4. Then we try to take the square root, but what's the problem here? You can't take the square root of a negative. You're going to get an error. That's an imaginary number. It is not real. Okay, so that's telling us, remember the zeros is where it crosses the x-axis. So how does this graph show there are no zeros for this function? It doesn't cross the x-axis. Okay, so if it doesn't cross the x-axis, it has no real zeros. So when a quadratic is solved algebraically and does not have real zeros, the parabola when graph will not cross the x-axis. So which of the following has no real zeros, determined by using the quadratic formula and verified in your calculator? Well, we know the zeros, y would have to be 0, x squared plus 7x plus 1 is equal to 0. All right, so A will be 1, B will be 7, C will be 1. X equals negative 7 plus or minus the square root of 7 squared minus 4 times 1 times 1, all over 2 times 1. Okay, now just to save a little time, this is going to work out to be 45 all over 2. So, will this have real zeros? Yes. This has real zeros because that part is a real number. It is irrational. So if your square root is a real number, then this will have real zeros. It'll cross the x-axis somewhere. In this case, it's going to be some kind of decimal because 45 is an irrational number. All right, so let's take a look at this one. 3x squared plus 2x plus 4 equals 0. A will be 3, B will be 2, C will be 4. X equals negative B would be negative 2 plus or minus the square root of 2 squared minus 4 times 3 times 4, all over 2 times 3. Now when I do this, I get negative 2 plus or minus a negative 44. So this is